Okay, now let's look at the two-phase liquid vapor region. Now we're somewhere in there. We're not all a liquid. We're not a vapor. We had to figure out what's going on. And you can see how this table is going to work out for us in that case. We are going to look at specific volumes, internal energies, enthalpies, and entropies, and they're going to give us the information for what happens if it's saturated liquid, which means it's on this line, what happens if it's saturated vapor and it's on this other line, and we're going to label that with VF and VG, or that subscript F and G all the way along as we go through here. So as you can see, everything on this blue line here, everything that's a saturated liquid is going to be listed down here in this saturated liquid table, saturated liquid column, and everything that's over here on the other side is going to be in the saturated vapor column. Okay, that's very important. So we're just listing everything there. And you're going to use the quality equation to find out what you have between there. Now here's a very special note that you have to look at, a very special note. For saturated liquid specific volume, the table heading that you're going to see there is VF times 10 to the third. Okay, so if we look at 8 degrees Celsius, VF times 10 to the third is equal to 1.0002. Okay, now that doesn't mean 1.0002 times 10 to the third. What that means is that they took the value of a specific volume times 10 to the third and they put it into the equation, or put it into the table. So what you need to do to get it out of the table is divide by 10 to the third to find out what your actual value is. So what the actual value here is not 1.0002. It's not 1.002 times 10 to the third. What the actual value is 1.002 times 10 to the negative third. Okay, times 10 to the negative third. Again, they took this value, because it's so very small, took it times 10 to the third, put it in the equation, put it into the table, so it was a little bit easier to put everything down here. So make sure that you read what the heading is here before you use the specific volume in your calculations. It's very tricky when you start to get used to this. Okay, so let's look at how we determine the specific volume. We use the quality X. Okay, so remember how we said here volume is volume liquid plus volume vapor, and I went through this derivation of you that I showed how we come up with this quality equation, VF plus X times VG minus VF. Okay, now we also said that pressure and temperature are not independent properties here. So in the two-phase liquid vapor region, we can't just know a temperature and a pressure to fix our state. We have to fix our state in some other way, and we're going to use the quality equation to help us find and fix that state. Okay, so let's do an example of this. A system contains a two-phase liquid vapor mixture at 6 degrees Celsius at a quality of 0.4. Determine the specific volume in meters cubed per kilogram of this mixture. Okay, so the solution here is what we're going to do is we're going to say, okay, we know we're a two-phase liquid vapor mixture. We need to use this equation. We need to use this quality equation. And so I'm going to go here and I'm going to go down into my table and I'm going to look at 6 degrees Celsius. I'm going to find my values for my saturated liquid and my value for my saturated vapor. And I'm going to remember that my saturated liquid is going to have that times 10 to the minus third that I have to put in here. Okay, and now I'm just going to plug and chug. It looks like I made a mistake here. I need to put 1.0001 times 10 to the negative third. I'm going to put that in here as VF plus my quality, which is given to me as 0.4. I'm going to put here times 137.734 minus 1.0001 times 10 to the negative third, and I'm going to find that my quality is equal to, or my specific volume at 40% is going to be equal to 55.094 meters cubed per kilogram. And that makes some sense. We're not halfway there. We're a little bit less than halfway. 55.094 makes perfect sense. And I encourage you to look at that. If you were to calculate this number and you were to get a number that's equal to 140, you know that's wrong because that's larger than what it would be as a saturated vapor. You know you made some terrible mistake. If you found your answer was equal to 95, you would say, oh, that looks like it's closer to the saturated vapor than to the saturated liquid. I think I need to calculate this again. So please look at your numbers. Please look at your values there that you calculate and see if they make some sense before you use them in your other calculations. Okay. Now, with where we are right now, I feel like that is. Let me see here. What if I have another statement? Yeah, I have an example problem that I'm going to run up with you tomorrow as I'm doing this. What I want you to do today is just be familiar with these tables and kind of start having some understanding. And what you probably got right now from looking at this was just, what? What did Wanklyn just tell me in the last hour of my life? And I understand that. We are going to take all class period tomorrow and really dive into how do we use these tables more. So if you haven't had a chance to print out your tables, I would encourage you to do that today. Print out your tables, get those bound somehow, whichever way you feel safe in doing that. If you need to go someplace or you need to, I don't know if you can order something to be printed and pick it up curbside or whatever need be if you don't have a printer. But I would encourage you to get a physical copy in some way. I think that would be very helpful for tomorrow's class, because tomorrow we're just going to open it up, look at those values, try to find values out of that table, and start learning that skill, which is property lookups. Okay? Until then, I hope you have a good rest of your day, and we'll go from there. You know what I'm going to do? I've decided here, I'm not going to assign homework today. That will make things a little bit easier. I'm not going to assign homework today. I'm going to assign homework tomorrow in class. It doesn't make any sense for you to be working on things when I just don't think it's going to be as solid as what I want it to be for you to have a good homework assignment without being floundering around a little bit. So there's going to be no homework today, no homework due on Tuesday. So a little bit of a break for you for this exam, and then we'll hit it tomorrow, and then I'll give you some homework tomorrow. So that's what we're going to go there. All right. Thank you for paying attention. Hopefully you're paying attention, and we'll see you again on Friday.